Next, we want to find the Maclaurin series for the function f of x equals e to the x and its radius of convergence. So what do we need to do in order to find this series? Well, we need to know what the nth derivatives of our function are. Our f of x is e to the x, so the nth derivative is also e to the x. Since this is a Maclaurin series, we want the nth derivative at 0. So this would be e to the 0. That would give us 1. Okay, that means if we go back to our f of x formula, we've got the sum from 0 to infinity of the nth derivative at 0, that's 1, times x to the n divided by n factorial. We should note that for n factorial, 0 factorial is defined as 1. All right, so our Maclaurin series for e to the x is x to the n divided by n factorial. The second part of this question asks for the radius of convergence. So in order to find convergence, we could use good old ratio tests. So I'm going to put part A for Maclaurin and part B. So let's do the ratio test, and we have the absolute value of x to the n plus 1 over n plus 1 factorial times n factorial over x to the n. Notice I've already taken the reciprocal and multiplied there, and we want the limit as n approaches infinity. I feel like maybe we've done this example before, but we will continue to do what we do and write it as x to the n times x times n factorial over n plus 1 times n factorial times x to the n. The x to the n's cancel, the n factorials cancel, and we're left with x divided by n plus 1, which we know that limit goes to 0. What that means for us is x could be all real numbers. Since this limit goes to 0 and that 0 is smaller than 1, this thing converges, or the radius of convergence is infinity. Now, what if we had wanted, instead of the Maclaurin series, what if we had wanted the Taylor series of the function? Let's do Taylor of e to the x, where a is equal to 1. So we want the Taylor series centered about 1. So what do we need? We need, scroll back up here, we need to know the nth derivative evaluated at a, and we want x minus a to the n in our problem. So what is our nth derivative? Well, the nth derivative of e to the x is just e to the x. We want this nth derivative evaluated at 1, so this is e to the first power. So our f of x expansion becomes the sum of e times x minus 1 to the nth power divided by n factorial is our Taylor expansion at 1.